All right, number 28. The 22 students in the health class conducted an experiment in which they each recorded their pulse rate in beats per minute before and after completing a light exercise routine. The dot plot below displays the result. Okay, so at the beats per minute before exercise and then beats per minute after exercises. All right, let S1 and R1 be the standard deviation and the range, respectively, of the data before exercise, and S2 and R2 be the standard deviation and range, respectively, of the data after exercise, which I'll find is true. Okay, seems like we're trying to compare the standard deviation and the range for both of the data set. Okay, so let's do the range first. Okay, range will be easier to think about because the range is the difference between the highest number and the lowest number. Okay, so to find the range is always the highest number minus the lowest number. Okay, so you look at the two data set here. So for the first one, the number went from the lowest number that we have is 56. And the highest is 88. So for the first data, the range is, so that'd be R1, the range is 88 minus 56, which is 32. Okay, that's the first range. And the second one, the range is, so we have a number at, the highest one is 112, right? Okay, and the lowest one's 80. So we'll do 112 minus 80, which is 32. Okay, well, so look at the range, they happen to be the same. Okay, both have the same range. So R1 should equal to R2. All right, so which one has that? Okay, R1 equal to R2. Then it should be either answer choice A or answer choice D, right? So you can eliminate B and C. Okay, okay. And then between A and D, A says S1 equal to S2 and D says S1 is not equal to S2. So all we have to think about is whether the standard deviation will be equal or not. Well, if you look at the data sets here, what happens, the standard deviation is the measure of spread and is telling us how spread out the numbers are, right? If the numbers are very closely together towards the middle, to wherever the average is, then it should have a smaller standard deviation. Okay, so the word deviation is difference, right? So standard deviation tells us how the data on average, how much it deviates from the mean, right? How different it is from the average, right? So if all the numbers are very close to the average, has a smaller standard deviation, right? So number are more spread out, then it has a larger standard deviation. Okay, so you can see here in the first data set, see how these numbers are very clustered together toward the middle, right? So it should have a smaller standard deviation. Compared to this one, all the numbers are more evenly spread out. Then it has a larger standard deviation because most of the data are further away from the mean. Okay, right. But for this question, all we need to tell is that the standard deviation should be different. Okay, it should be different. So then it should be D. Okay, so unless the numbers are exactly the same, if the two data set looks exactly the same, then they will have the same standard deviation, right? So for something like this, we can clearly tell that, yeah, is the spread is all over the place, right? It's different. So yeah, so for something like this, the standard deviation have to be different. Okay, we don't need to solve it mathematically. We can tell here based on how spread out the numbers are, we know they should be different. Okay, so that should be it for number 28, which is letter D.